little bit of what we covered in class on Friday is the definition of a derivative. Definition of a derivative. Alright, but before we do that, we're going to review a little bit on function notation. Alright, if I tell you f of x equals x cubed plus x, well, what if I ask for f of y? Well, I'm going to take y and plug it in for x. So instead of x cubed, I'm now going to have y cubed plus y. Same kind of thing. Well, what if I were to ask you, in this again, what if I were to ask you f of smiley face? Well, all that means is we're going to stick in a smiley face everywhere I see x. So it's smiley face cubed plus smiley face. Same thing if I asked you something like f of heart. Okay. Well, everywhere I see x, I'm going to write a heart. So heart cubed plus heart. Okay, y'all get the point. Anything that's inside that parentheses becomes my new x value. So, okay, let's look at this. There's one thing I want you to pay attention to. If I tell you f of x is x squared, and I ask for f of x plus h, that equals this entire thing squared, x plus h quantity squared, not x squared plus h. Okay? Alright, moving on. Alright, let's go to an example similar to what we did in class. You remember in class I showed you that the definition of the derivative, and again this needs to be on your memory list, the limit as h approaches 0 of f of x plus h minus f of x all over h. Well, what it's going to ask you for is it's going to ask you to find the derivative if f of x is 8. So find the derivative if f of x equals 8. Well, we know our formula, but with this one we might want to think about a bit, okay? Is if I draw a horizontal line, if I draw a line here, and, well, f of x equals 8, that's just a straight horizontal line at 8, correct? And I say this is x, and I say this point is x plus h, well, what are both of those y values going to be? Well, they're both going to be 8. So plugging it in, the f of x plus h, which we just noticed here at x plus h, well, I'm still at 8 because this is a horizontal line. And then what is my f of x? Oh, again, f of x we said is 8. Alright, and so now let's plug this into our formula. Our limit as h approaches 0 of, well, f of x plus h is 8 minus f of x, which is 8 as well, all divided by h. Now let's simplify. 8 minus 8 is 0. 0 divided by h is just 0. Well, again, that makes sense because remember I talked about the derivative is the same thing as the slope. And what is the slope of a horizontal line always? It's always 0. Okay, now I want to find the derivative of f of x equals negative 5x. So find derivative of f of x equals negative 5x. Alright, again, we're going to write our formula. the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. So first thing I'm going to do, all right, x plus h, remember function notation. I'm going to put, again, my limit rules apply. I still have to keep writing my limit. So negative 5 times x plus h, plugging in x plus h for x, minus f of x, well, that's minus a negative 5x, all divided by h. Now we just have to do some algebra. So distribute my negative 5 through, change my minus minus to plus. So, again, don't forget to write my limit. You have to keep up with your notation. Negative 5x minus 5h plus 5x. Minus a minus becomes a plus, all divided by h. Ooh. Well, now let's look at some things. Let's combine some like terms here. What can cancel? Well, negative 5x and positive 5x. So now let's look at what I'm left with. Limit as the h approaches 0 of negative 5h divided by h. Well, what happens with my h's? They cancel. Well, h divided by h is just 1, so they do cancel. So I'm left with the limit of negative 5. Well, okay, that makes sense, or the derivative is negative 5. Well, let's think about that. If derivative is slope, and this is the line of f of, of f of x is equal to 2x squared plus x minus 1. Okay, so the first thing I'm going to do is, again, let's write our definition again. The limit as h approaches 0 of f of x plus h minus f of x all over h. Do remember that that formula can show up on your memory quizzes. Okay, so now we're going to do my f of x plus h. So the limit as h approaches 0 of 2 times x plus h squared. Just a reminder that x plus h goes everywhere x is, plus x plus h minus 1, all minus 2x squared plus x minus 1. Everything divided by h. Now we're going to have to do some foiling and some distribution. Just a reminder that the limit as h goes to 0 of 2 times x squared plus h squared. X squared plus h quantity squared is actually x plus h times x plus h, x plus h minus 1 minus the 2x squared plus x minus 1. Okay, let's combine our algebra. Okay, so now the limit as h approaches 0 of 2 times x squared plus 2xh plus h squared. Here, guys, I just FOILed it all together in one step. Plus x plus h minus, should be x plus h, minus 1. And then I'm going to distribute my negative sign through. Negative 2x squared minus x plus 1. Everything divided by h. Now in this case, the last step, I have to distribute my 2 through. So the limit as h goes to 0 of 2x squared plus 4xh plus 2h squared plus x plus h minus 1 minus 2x squared minus x plus 1. Okay, let's look at what cancels. everything is still divided by h. So let's look at what cancels on top. Okay, well my 2x squareds cancel. I've got one positive and one negative. My x's cancel and my 1's cancel. Okay, so now I have the limit as h goes to 0 of 4xh plus 2h squared plus h, all divided by h. Well, now what can I cancel algebraically? Cancel all of my h's. And that h divided by h becomes 1. So, now I'm left with the limit as h approaches 0 of 4x plus 2h plus 1. All I gotta do now, really simple, really easy. See, it got a little ugly, a little nasty, and then it's simplified quite nicely. So now instead of h, I'm going to plug in 0. So 4x plus 2 times 0 plus 1, which is 4x plus 1. One more. Alright. In this case, we're going to do the limit. As h approaches 0, I have f of x equals x cubed plus x squared. Okay, so the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. Okay, so plugging that into here. Alright, my limit as h approaches 0 of x plus h cubed plus x plus h squared minus x cubed plus x squared. Everything is divided by h. One thing you need to know, any sort of binomial cubed is of x plus a cubed, it becomes x cubed plus 3x squared a plus 3xa cubed plus, or a squared, excuse me, squared plus a cubed. Alright, now let's plug this in real quick. The limit as h approaches 0 of x cubed plus 3x squared h plus 3x h squared plus h cubed plus, and again I'm foiling that x plus h out, so x squared plus 2xh plus h squared minus x cubed minus x squared, all divided by h. But again, this will condense quite nicely. So x cubes cancel, x squareds cancel. So the limit as h approaches 0 of 3x squared h plus 3x h squared plus h cubed plus 2xh plus h squared. Everything divided by h. Well, now what cancels my h's? So h cubed becomes h squared, h cancels, and an h cancels there. So now I'm left with the limit as h goes to 0 of 3x squared plus 3xh plus h squared plus 2x plus h. Now all I do is I stick in 0 everywhere I see h. So 3x squared plus 3x times 0 plus 0 plus 2x plus 0. Okay, well all those zeros cancel, and I am left with 3x squared plus 2x